This is our last problem for this set. So this is problem number 95, and a proton enters a region with uniform electric field of this value 5.0 along z-axis, volt per meter, and the magnetic field, uniform magnetic field of this value 5 times 10 to the power minus 4 along z-axis, and the proton has initial velocity of this value, and we know the mass of proton is this much. So again, the same formula for this as well to find out r, but we don't actually find out r, so we just going to replace this r to get the time period, which is just a ratio of circumference over speed. So you can replace the value of r to get t. So like this is r, and this will be the time period. So it says how far along the z-axis does the proton travels after it undergoes 3 complete rotations. So the time taken, the total time taken would be 3 times this, the time taken for one rotation. So this will be 3 times this much. As you can see, E causes acceleration along z-axis, so you can write like using kinematics, like F equals to ma, so that the acceleration along z-axis equals to the force along z-axis over mass. So that is again this, the electric force QE, as we know the force due to the charge, okay, QE over m. So position z as a function of t, and t equals to this much. You can write like this. This is simple kinematic formula. Z equals to half a z t square. So we have the value for az, and this is t, and it's squared. So all the values are given, so you'll be able to find out the value of z. So the proton travels 37 meters in z direction after it undergoes three complete revolutions.